Okay, so I'm going to be explaining epistasis using a door and key model. When we think about a trait like hair color, we would typically assume that one gene would control this trait. Example, allele A. But with a concept like epistasis, multiple alleles can control the expression of this trait. I know this is kind of an abstract concept, so I'm going to explain the door and key model to help explain a specific kind of epistasis. And we are going to be focusing on single recessive, where homozygous recessive a condition with two different alleles can exchange the expression of a trait. So once again, what the heck does all of this mean? So I like to think of these problems like a door and key model. So the door in this case would be at allele A, and the key would be at allele B. And we are still focusing on hair color. To get into the room for the apartment, we would need the address to the door A, which would get us to brown hair. But if we want to get inside, we need allele B to give us the key to get to blonde hair. So we're going to be looking at examples with a cross between these parents and these parents to see kind of how this would work. So looking at one of the phenotypes from the dihybrid cross, let's look at big A, big B, little b. So we have the big A to get us the address to the door, so we have brown hair, but we also have big B, which would get us the key to get into blonde hair. But let's look at, say, little a, big B, little b. We have the key to get inside to blonde, but we don't have the address to get to the door, so we're still at black hair. Okay, so let's look at big A, little b, little b. We have the address to get to the door, so we're at brown hair, but we don't have the big B allele, the key to get into blonde hair, so we're still at brown hair. So when we look at all of the possible phenotypes here, we get a ratio of 9 to 3 to 4. And we know this is epistatic because looking at a normal non-epistatic ratio, we would get a 9 to 3 to 3 to 1 for all of the phenotypes. So we know that this would be single recessive epistatic because this is a ratio that represents that. Looking at this, we can't use the ratio to know this is single recessive epistatic because it's not a dihybrid cross, but we can still tell based off of the phenotypes that there's some type of interaction here between allele A and allele B. So we can use the door and key model to help us get the ratio of possible expressions from a trait to see if multiple alleles are at work, which is the main idea of epistasis. The references used in this video are under Module 2, Presentation 12, Epistasis, as well as the book, but the artwork used is my own.